Let's consider our set of 4 numbers here, and this equation for calculating the r-permutations for this set of numbers. So for this set, we have n is 4 elements, and therefore the number of 1 permutations is 4 factorial over 4 minus 1 factorial, and that gives 4. Now similarly, when r is 2, the number of 2 permutations is 4 factorial on 4 minus 2 factorial, which is 4 by 3, or 12 possible ways we can arrange 2 distinct numbers chosen from this set. And similarly, the number of 3 permutations is 4 factorial over 4 minus 3, which is 1 factorial. So that gives 4 by 3 by 2, or 24, as we can see over here. And then when r equals 4, the number of ways we can arrange 4 distinct numbers is 4 factorial on 4 minus 4, which is 0, and 0 factorial is 1. So we get 4 by 3 by 2, which is also 24. So as we can see, for an r permutation, the order of the elements matters. So 1, 2 is not the same as 2, 1. But with an r combination, order does not matter. So therefore 1, 2 is treated as the same as 2, 1. So to calculate the r combination, we want to remove the duplicates from here. So for the case where r equals 1, we had the number of r permutations as 4 factorial on 3 factorial. And to remove the duplicates, so there are no duplicates here, so effectively we're just dividing by r factorial, which is the number of ways we can arrange one number. So therefore this is the number of 1 combinations. Now when r equals 2, we had the number of r permutations is 4 factorial on 2 factorial, and the number of ways we can arrange 2 numbers is 2 ways, or 2 factorial ways. So as we can see, 1, 2 can be arranged as 2, 1, 1, 3 as 3, 1, 2, 4 as 4, 2, and so on. So to remove those duplicates, we divide by 2 factorial. So this is the number of 2 combinations. And if we keep going, 3 numbers can be arranged in 3 factorial ways, or 6 ways. So we can see this for 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So again, calculating the r combinations from the r permutations, we're dividing by 6, or 3 factorial, to remove those duplicates. So again, order does matter for r permutations, but it does not matter for r combinations. And finally, when r equals 4, we can arrange these numbers in 4 factorial ways, or 24 ways, as we can see by these r permutations. So therefore the number of 4 combinations is the number of 4 permutations, which is 4 factorial on 0 factorial, and we divide by 4 factorial. So from this, we can get a general equation for the number of r combinations. So we have a set of n elements, and r distinct elements chosen from this set of n elements, which we can also denote as follows. So the number of r combinations is the number of r permutations, as we can see, and we're just divided by r factorial. So you can see the pattern here. So our general equation for the r combinations can be written as n factorial on n minus r factorial by r factorial, which we got from this expression over here that we derived earlier.